Hello and welcome to Planning for Heat, what you need to know about heat pumps. This webinar has been specifically designed for planners and environmental health practitioners working in local authorities to help you understand the evolving landscape of air source heat pump technology and regulation. This webinar can count towards your CPD, so to claim your CPD certificate, you need to fill out a form by the 30th of January 2026. The form will be emailed to attendees after the webinar for them to claim their CPD certificate. And for those watching this webinar as a recording, please follow your host website instructions on how to receive your CPD certificate at the end of this video. The objectives, so just to say that I'm just going to put the slides up now. Here we go. So yes, the objectives of this session are to understand the importance of air source heat pumps in decarbonising UK homes, the updated planning rules, and how permitted development rights work for air source heat pumps, the MCS 020A standard for permitted development rights, common concerns around sound, cumulative noise and how that works for air source heat pumps, and how to balance the limiting adverse effects on public health plus limiting the burden on the planning system. And then finally, we'll wrap up with some news on the imminent guidance from the Institute of Acoustics and the Chartered Institute of Environmental Health. So firstly, why care about heat pumps? We know that heat pumps essentially are going to be doing the heavy lifting of net zero. So we know that essentially half of homes will need heat pumps in the next 15 years. You know, the Climate Change Committee has said that we need to get rid of all oil and gas boilers to reach net zero. And air source heat pumps in this picture here are expected to make up the overwhelming majority of installations of heat pumps because they're generally cheaper and easier to install in existing urban and suburban homes compared to ground source systems. So there are some common misconceptions about heat pumps. They do work really well in the cold. Over half of homes have heat pumps in cold countries like Norway, Sweden, Finland. And I have a heat pump myself, and I can attest my Victorian terrace is warm 24/7. While insulation leads to lower bills with any heating system, there's no requirement to insulate the home first before installing a heat pump. And modern units are quiet and comparable to a fridge or a dishwasher, and we'll talk more about that later. For more information about heat pumps, and you can refer your residents to getaheatpump.org.uk, which is a resource, it's a website from Nesta and MCS Foundation that can tell you a lot more about heat pumps. But the main thing to say here really is that we really do expect that heat pump planning applications will rise as more and more homes take up heat pumps. So what does this mean for you? Essentially, we know that between 10 and 15% of installations require a planning application, but most domestic installations can be completed under permitted development, provided they meet certain conditions on size, siting and sound levels. The rules in England changed in May 2025, and I'll go through those now. So in England, for permitted development, there are rules under size, siting and sound, and these are that in England you can put 1 unit per block or 2 if it's a detached dwelling. Similarly, on size, you can have a heat pump up to 1.5 cubic meters, but for flats that's 0.6 cubic meters. And then siting, you need to get a planning permission or put through a planning application if it's on a pitched roof, if it's on a flat roof and within 1 meter of an edge of a flat roof, listed buildings and facing a highway and conservation areas. And finally, and we'll talk a lot more about this, essentially it needs to pass the sound limit, which is the MCS 020A. I'm now going to talk a little bit more about regional variations. So Wales, the size limit is now 1 meter cubic squared. This is likely to change shortly. And also there's a 3 meter rule where you can't put a heat pump more than closer than 3 meters to a boundary, unless you seek a planning application. The government's already released its consultation, and we know that they will be removing that 3-meter boundary soon, that rule. Similarly to how in England they removed the 1-meter rule in May last year. In Scotland, the rules are slightly different. So 3 meters, up to 3 meters high, higher than 3 meters, you'd need to seek a planning application. Siting, if it's more than 1 meter from a home. And then similarly, all 3 nations follow the MCS 020A. So I'm going to talk a little bit about the planning applications that you receive because of size, number, or location. And then Scott's going to talk about, from MCS, is going to talk more about sound levels. So the first thing to say here is that you can safely install air source heat pumps on walls or roofs. And often this is chosen because of practicalities, sometimes to make sure that they're closer to internal hot water tanks to reduce installation costs, and also not lose that heat from the heat pump as it has to travel further to get to the hot water tank. Here are just some examples of a few heat pumps on roofs and pitched roofs, flat roofs, and mounted on the side of buildings. Heat pumps are necessary infrastructure like utility meters, pipes, rubbish bins. And while aesthetics are a common concern, heat pumps often, they're smaller than sheds or bicycle storage. And there are lots of ways that they can blend in. So here are some examples and some others. And they are becoming an attractive feature of a modern smart home. And as I said, they are a lot smaller than, this is an example of bike storage allowed under permitted development. They're much smaller than that. So to summarize, you can safely approve applications that are made because of the size or the siting. With number, as Scott will talk about, the MCS calculations allow you to put in multiple, but as long as that you're meeting the sound limits, there's no reason to have to reject an application on the basis of number. You can see that as long as they meet the sound level, feel free to approve where there's more than one being installed per property. And so to say that at Nesta, we believe there is scope for these permitted development rules on siting and size to be simplified and streamlined even further. But today I've explained what the rules currently are. And now I'm going to pass to Scott from MCS, who's going to discuss those sound limits and the MCS 020 framework in more detail. And Scott, I'm controlling the slides, so just let me know when you want to move on.
That's brilliant. Thank you, Katie. Could you move to the next slide, please? Brilliant. Thank you. So, good afternoon. My name is Scott McBride, and I am the Technical Manager for Heating at MCS. Now, MCS is a standards organisation. We're the UK's quality mark for renewable energy systems like heat pumps and solar panels that are installed in homes and small businesses. Now, our role is to set clear standards and protect consumers, giving everyone confidence in homegrown energy. Now, membership of MCS demonstrates an adherence to recognised industry standards, which highlight quality, competency and compliance. Our vision is to see MCS certified products and installations in every UK home and community. And our objective is to give people confidence in low carbon energy technology by defining, maintaining and improving quality. Next slide, please, Katie. Now, MCS 020 was originally drafted in 2011. It is the standard document designed to set out the sound calculation which must be conducted for domestic installations of heat pumps to be permitted development. It includes a calculation procedure designed to confirm whether the permitted development noise limit of 37 decibels would be met. The standard, the steps, and the calculations carried out by the installer can then be used by local planning authorities to verify compliance. It was written by the MCS Heat Pump Technical Working Group and acoustic experts, and a proposed update to MCS 020 went into consultation in January 2024. Now, this update was driven by the government's consultation and then announcements on amendments to existing permitted development rights that apply in England. The update to 020 aimed to simplify compliance and improve clarity for installers. These were then implemented in April of 2025. So looking at the changes, compliance with MCS 020A under PDR will apply irrespective of whether it's an MCS certified installation or not. MCS have now updated clarifications. So we've described what can and cannot be considered a solid barrier or a reflective surface. We've clarified how to determine the assessment position and have now added the definition of a habitable room, which are the rooms that need to be considered as assessment positions. The calculation now allows for 2 heat pumps to be installed on one property, bringing that in line with permitted development rights. And the Excel tool now allows up to 4 heat pumps in total for those intending to install under full planning permission. Compliance with this update is mandatory for installers seeking to install air source heat pumps under permitted development from the date of implementation, which was the 20th of September 2025. Now, compliance with MCS 020A on its own does not bestow permitted development rights, as there are other conditions such as location and heat pump size, which must be complied with for an installation to be permitted development. Next slide, please, Katie. Now, MCS have provided options for completing the sound calculation, which will include a paper-based method and an Excel tool. This tool will calculate the sound pressure level, which under permitted development rights cannot exceed the noise limit of 37 decibels. To complete the sound calculation, we need 4 things. So that's the A-rated sound power level, the amount of reflective surfaces, the distance from the heat pump to the assessment position, and then what type of barrier is in between the heat pump and the assessment position, if there is one. To begin calculating the sound pressure level, first you need to determine the assessment position. So you can consider multiple assessment positions and carry out an assessment for each, as the closest position isn't always the one with the highest sound pressure level. For example, an assessment position could be much further away but have a clear line of sight with no barrier in between. Now, assessment positions should include neighbouring properties on all sides of the property where the heat pump is to be installed, and include assessment positions on the ground floor, first floors, etc. So you'll need the A-weighted sound power level, which is the total sound energy radiated by the heat pump. Now, this should be attained from the manufacturer's data, which can be found on the product fiche, the product energy label, and soon these will be available on the MCS product database. Next slide, please, Katie. So you'll then need to determine the directivity of the heat pump noise. So this is done by identifying the number of reflective surfaces there are. So a reflective surface is any surface, which includes the ground but not vegetation, within 1 meter of the heat pump. A heat pump with more than 3 reflective surfaces, for an example, one within small light wells, will not meet MCS 020A. You will then need to measure the distance from the heat pump to the assessment position in meters. This is measured in a straight line between the center of the heat pump unit and the assessment position, more specifically 1 meter external to the center of a window or a door. A correction factor will also need to be applied if there are any barriers between the heat pump and the assessment position, and you'll also need to determine the line of sight. For instance, a correction factor of -10 decibels will be applied if there is a solid brick wall that fully obscures an assessment position. The definitions for barriers are type 1, which is a solid brick or masonry wall that's at least 18 millimeters thick. Barrier type 2, which is a solid fence that is less than 18 millimeters thick. And then no barrier, which includes open fences with gaps and cracks or walls in poor state of repair, really. The options for line of sight are no view. So this is a barrier that completely obscures the vision of an assessment position from the top edge of the heat pump. You've got partial view. Now this applies if you move a quarter of a meter in any direction from the heat pump and can see the assessment position. And then finally, full view, which is when the assessment position is completely invisible from the top edge of the heat pump. So once you've completed these steps, you'll have everything that you need to complete the sound pressure level, or to calculate the sound pressure level. Next slide, please, Katie. So it's important to meet the sound limit, as installations that don't meet MCS 020A do not benefit from the permitted development right, and you may need to submit a planning application. Now, if the intended installation has not received the 37 decibel limit in MCS 020A, there are some adjustments that can be considered to lower the overall sound pressure level at the assessment position. So firstly, check if it is possible to locate the heat pump unit more than a meter away from a reflective surface. This will remove that surface from the equation. Using a heat pump with a lower sound power level will reduce the overall sound pressure at the assessment position and can potentially make a big difference. If a sound barrier is not already present, then consider whether it's possible to install one. You see, barriers have got the greatest impact on the reduction of the sound pressure level if they completely obscure the view of the assessment position from the heat pump. The 020A standard provides a matrix that covers the decibel reduction applied for the different types of barriers and line of sight. You can then also ensure that the correct assessment position has been selected. So the closest neighbouring habitable room does not necessarily mean that's the most susceptible to the sound emitted from a heat pump. And if the heat pump has already been installed and has begun to make more noise, it could be a maintenance issue such as a loose screw or even leaves caught in the fan, which can be fixed. Next slide, please, Katie. Now, MCS have consulted with the Department for Energy Security and Net Zero and the Heat Pump Technical Working Group to produce an installation guidance document on mitigating noise from air source heat pumps. So it can be used by local authorities, installers, homeowners, or even neighbours who are seeking guidance on mitigating the acoustic impact from heat pumps. This guidance document is to accompany MCS 020A and permitted development rights. It covers the installation guidance on reducing sound from air source heat pump installations, what to do if a proposed installation has failed the 020A assessment, what to do if a heat pump has become noisy or had a noise complaint, and it goes into detail as to why heat pump noise is a concern. Now, this document can be found on our website at www.mcscertified.com. Next slide, please, Katie. I think that's it. Brilliant. And thank you all for listening. And now I will pass you over to Jack Harvey-Clark from Apex Acoustics, who will be discussing the latest and ongoing research in heat pump acoustics. Thank you.
Thanks very much. Am I operating my slides now? Is that yes? Great, thank you very much. So my name is Jack Harvey-Clark from Apex Acoustics. I've been an acoustic consultant for 25 years, but I started finished my education and started my career working in power generation. So it's nice to get back to working with heat and power again here with the acoustics of heat pumps. So I'm going to talk a bit about the past and present research that's gone on to understand noise from heat pumps. What can we do about it? I'll expand a bit on some of the things that Scott talked about there and talk about the imminent planning guidance that we had strongly hoped would be issued before today, but which is just about to be issued by Institute of Acoustics and Chartered Institute of Environmental Health to help you. So we've been doing assessments of heat pumps for many years, but we got deeply into the research back in 2022 when we did some work for the Welsh Government on noise, looking at the extent to which noise was a barrier for installing heat pumps in Wales. And then that was followed up by a bigger project by DESNZ, and we collaborated with Salford to contribute to one of the chapters on that. So as a result of all the work and investigation we've been doing, we've been writing conference papers over the last few years, and now I've started organising conference sessions at international conferences on noise from air source heat pumps. So it's nice to hear from our European and other international colleagues what they're doing, and because this is a problem for many people. So currently we're undertaking a project which is jointly funded by MCS and Nesta on reducing the acoustic barriers to air source heat pumps, and I'll tell you a bit about that. And I'm also involved in a personal capacity in the IOA Renewable Energy Action Group, developing this guidance that I've just mentioned is about to be issued for consultation. So the problem that we're all facing, or that is maybe going to become a bigger problem, is that on current assessments, 25% of proposed installations fail the MCS noise test. So a large proportion. And you can see from the graph there that actually a quarter of those that fail by 1 dB. So 6% of the total, but that's a quarter of the ones that fail by just 1 dB. We know how many heat pumps we need in the country, so this is potentially an awful lot of sites where people either get put off installing heat pumps or they have to apply for planning. Applying for planning for most people is a barrier because it's additional bureaucracy and cost and time, and they don't want to do that. So avoiding planning is one thing, but if it goes through planning, that's what we're thinking about here. How can we provide guidance to help you? So this is part of the context of this project that we're doing for Nesta and MCS. It's got 3 strands to it, and this is looking at, can we update MCS O2O calculation to make it more accurate? We're doing this in 3 ways, taking 3 approaches to this. One is by doing modelling, because there's a very simple noise propagation model in the MCS O2O standard. And so we're comparing that with detailed calculations that we would typically do using software to ISO 9613. But to check that the modelling is valid, we're going to do some in situ sound propagation testing, and to check that what we're doing is valid there. And the other half of it is looking at auditing existing installations, because at the minute all assessments are based on the stated sound power level in the manufacturer's data. And how does that relate to the sound power that's actually emitted by heat pumps in practice? We don't know very well that. So this is some of the modelling. We've nearly concluded the modelling now, and headline results are: we think that on average that if we use detailed modelling, we're predicting levels between 1 and 6 dB lower than the MCS calculation is predicting. So it looks like MCS O2O is pretty prudent, perhaps excessively prudent, because if it's too prudent, of course, that kicks these applications into planning, which we all want to avoid as much as possible. This is the model air source heat pump speaker that we've built. We haven't yet calibrated it, but we'll be calibrating it, and then we'll be using this to do various tests to make sure that the modeling differences that we're evaluating are valid to use in practice, and seeing how we can update MCS. And the other side of it is the in situ audits. So heat pumps sometimes operate in stable, consistent conditions, but sometimes not. Operation varies. So we are doing lots of measurements around heat pumps to find out how long we have to measure for, and to develop a measurement protocol. That doesn't exist at the minute. So that should help with consistency of evaluating complaints, which I'll come on to. One thing which many people are concerned about is cumulative impact. If everybody gets an air source heat pump, is there going to be a problem in the environment? So we did some detailed modelling a couple of years ago, and this report is on the Nesta website. We looked at the densest possible terraces and semi-detached archetypes that we could find. So this model here is of the semi-detached, just because there's a little gap between those rows of houses. And our conclusion from this work was that your obviously the biggest impact on your own house is your own heat pump. And then the next most significant impact is your nearest neighbour's heat pump. And although everybody else has a heat pump that's operating at the limit of the sound power levels that's allowable in the neighbourhood, your nearest neighbour's heat pump is still a more significant impact, we think, than all the others together. And in fact, Salford have done some research which corroborates this from an entirely different perspective, just from listening tests. So that'll be interesting. That's not published yet, but will be soon, I hope. So what are the design options for these 25% that fail at the minute? As Scott mentioned, one thing you can do is select a quieter unit. That's not a simple thing to do, though. We do know that this is a sample of a small range of popular manufacturers. So there is a wide range in sound power levels for any given level of heat output. But selecting a different manufacturer usually means going with a different installer, so potentially starting the whole process again. So it's not an easy thing to do. Can you move it further away? Scott also mentioned, yes, potentially, but this obviously has a thermal impact on the performance. People ask about orientation. So we've looked quite a lot into directivity, and we think that actually air source heat pumps aren't generally very directional. So it might seem like all the noise is coming out in the direction that the fan is blowing. But I think when it's noisier, the compressor seems to be producing a lot more of the noise than the fan. And the noise is coming out in all directions. So that's not much of an option to orientate it differently. There is an option to use barriers, and I think nearly half the applications that pass do have barriers in them, and only about 6% of those calculations that fail had barriers in them. So a barrier is a good option if it's possible, but it's not necessarily straightforward to build one if there's not a natural barrier in the location that you want to put your heat pump. So might not be easy. Acoustic enclosures, last resort, big thermal compromise, and most manufacturers say don't do that. Other design considerations are to do with structure-borne sound, if putting them on lightweight structures, whether that be walls or roofs, that can be a problem for the owner themselves. And an option to use quiet mode, which people might want to use for their own benefit at night, but I'll talk more about the opportunities for quiet mode as well. So at the minute, there's no standard protocol for measuring the noise from heat pumps when investigating complaints, but this is one of the things that we are developing in our project as well. And so as part of this, we need some sites to test these protocols that we're developing. So if you have any complaints, please do get in touch. We will do in situ measurements. We'll do interviews with the residents and if possible the neighbour. And if the occupier consents, we will share the data. We obviously won't be determining whether or not it's a nuisance. That's your job. But we can be collecting data on it to help inform those things that lead to complaints. I know there was that survey a couple of years ago that you might have seen from the Institute of Acoustics on complaints, which has been helpful, but we want to bring this information up to date, and there were never any noise measurements associated with that survey. So do get in touch if you've got a complaint. It's interesting to see what other countries do, and this is a very high-level summary of Austria, Switzerland and Netherlands approaches. So most countries in Europe have zonal planning systems, and they expect to have different sound level limits for daytime and nighttime periods. So you can see that our sound level limit of 37 dB is essentially a nighttime limit, and pretty much every other country has a higher daytime limit. Actually, Scotland already use fixed limits frequently, and many local authorities in Scotland have higher limits for the daytime than the nighttime. So the most common nighttime limit is NR25 inside, which is probably a bit higher than our current 37 dBA outside. So 37 dBA outside is probably more prudent, that's in the MCS calculation. So where they have daytime limits, they're usually 10 dB higher. This is really important because the joint IOA-CIH Professional Advice Note 2026 that is just been written but not yet published, so it's just about to come out to consultation, is what it says at the minute. The agreed position is that in the guidance is that you can rely through planning on MCS 020A if you need to. So if a heat pump application is going through planning because it doesn't get PDR for non-acoustic reasons, then you should be able to rely on MCS calculation. That adds the minimal additional burden to the applicant. And the one option is that if you're in planning because you failed the MCS 020A calculation, you can use, or a suitably qualified acoustician can use noise modeling software to predict the noise level. As I mentioned before, we think that might give between a 1 and 6 dB advantage in terms of could demonstrate compliance with the 37 dB criterion with a more sophisticated noise modeling technique. And the level 2 assessment is essentially full BS 4142, so much more significant additional cost. So a level 1 is still going to be additional cost for the homeowner, because that's a piece of work that will need paying for. And that is in itself an obstacle. So other options that you might want to consider in planning are the use of quiet mode at night with a higher daytime limit. So even if the daytime limit was just 5 dB higher than the nighttime limit, this would unlock a great number of sites for people with the minimum additional burden, because this is essentially free for the installer to set the heat pump up like that. And not all heat pumps have a night mode, but all those heat pumps that are designed for the general North European market, so other European countries, typically have a night mode. Another option is to allow a higher impact where the background noise is higher, and you might take a view on what the background noise level might be depending on the location as a desktop exercise, and that would then reduce the cost of a survey for the applicant. So these are things which are not in the professional advice note at the minute, but I'd be very interested to hear your views on the higher daytime limit. So we know that air source heat pumps are vital for decarbonising heat, but we know it's essential to get the noise right. We've seen noise be cited in the national press as a reason to scare people about heat pumps. One of the problems that all of us who are trying to measure noise from heat pumps have is that they're so quiet, it's very difficult to measure. You have to be in a pretty quiet location to start with, or wait until the middle of the night. You don't want a load of planning applications coming across your desk, so MCS will do what they can to make their assessment tool as more accurate as possible and reduce those number of installations which get forced into planning just because they don't comply with MCS. And hopefully the guidance produced between the IOA and the CIH will help smooth that passage through planning where things have to go through planning, so it takes as little of your time as possible. So do get in touch if you've got any complaints that we can help you investigate. Thank you very much.
Brilliant. So now we're going to move on to question and answers. I'll try and start from the top. Right, let's go for. Quite a few people have liked this question. So some local councils or boroughs have their own noise generating or noise sensitive development planning documents, and they specify more stringent noise levels, especially at night. And if an installer uses the MCS noise assessment and got a pass, but for local requirements, it's not acceptable, like who's right here? Because he said that sometimes architects won't accept the MCS calculations. My answer would be that if you follow the if it passes MCS and it passes permitted development, then it should pass, and then therefore it's correct that it's fine. The issue is if there's an Article 4, some councils have areas where they put additional rules in place. But as far as I understand it, I don't know if anyone wants to correct me. If you're passing MCS 020 and all the other permitted development rules, then it is allowed, and that should be relied on.
I agree with you, Katie. MCS 020A is referenced in permitted development rights. So if the sound assessment, or if you run through that calculation and it achieves the 37 decibel limit, then that is classed as permitted development on the sound aspect anyway. Yeah.
Brill. And then moving on to Wendy's question. So she says, we often have consultants who don't want to do a noise assessment for those that need a planning application and state that it only exceeds the 37 decibels by a couple of decibels, so shouldn't have to do a full assessment. This is a £1,000 to £2,000 assessment. Wendy disagrees, and what are your thoughts when they don't comply with the limit of 37? I think I would say that the often people with the government grant, people are getting a heat pump sometimes for £1,000 or £2,000, and so if you're asking them to pay for planning and to do this assessment, it often would mean that they wouldn't go ahead. And I think that is a real shame when we really want people to get heat pumps. And so we need to be careful encouraging or passing on those costs when potentially we've talked through a lot of ways that you can improve things. And also there can be judgment if the area is quite a loud area, like more of an urban area. I'll pass this one to Jack.
So which bit, sorry, are you passing to me?
Well, if someone says, "Oh, it only passes, it's only a few decibels over 37," should I send them for a £2,000 sound?
Yeah. It seems harsh, doesn't it? So I think there's quite a lot that can be done from a desktop point of view. So what we would be considering in this case, or be encouraging environmental health officers or planners to do, is consider from a desktop perspective what the background sound in the area is likely to be. So what type of environment is it? From their local knowledge, how noisy is it? You could look at the national noise maps to inform noise levels. You could look at information in planning applications where they'd had noise assessments nearby to see what the background noise levels have been measured to be. All these things, anything you can do from a desktop point of view, of course, is much cheaper than asking somebody to go and do a noise survey. But it's we know, of course, that planners don't accept information that's been submitted for another application for a site in question. So it is a bit of an ask. And if there was some more guidance on getting information on background sound levels, that would be really useful, I think, to help address this. There's not that. We have the national noise maps which talk about ambient sound from roads and railways, but we don't have anything that directly informs background sound.
Makes sense. Anything you want to add, Scott, on that?
Yeah, when it comes to the 37 decibel limit, if a heat pump fails by just a slight amount, we would highly recommend that you consult noise mitigation guidance. Main focus is to, I can imagine from a planning officer's perspective, is that we don't want more noise complaints. So following the procedures to mitigate heat pump noise, I'd say is paramount at that stage if it fails the 020A assessment.
Brilliant. Okay, I'm going to move on to Greg's question, which is who should be checking MCS 020A sound calculation as part of a planning application? Some planning departments appear to just accept the calculations as okay if submitted. And okay it. Are planners happy to check MCS 020A sound calculations? Do they defer to environmental health or similar, or should they usually be checking with environmental health? I think if I'm understanding what you're saying, what we're saying and what the guidance that's going to be consulted is saying is that if it passes MCS 020, that should be an approval it wouldn't need to go to get more views, if that makes sense. But Jack, maybe you can correct me if I'm wrong.
I think it's an interesting question, because as part of the work we're doing, we're looking at lots of planning applications for air source heat pumps. And it's surprising the wide range of interpretations of MCS 020 that we're seeing people do. So I think it's a good question, and I guess by the time it's in planning, that it would be environmental health who are checking that the calculation has been done appropriately. If the route is just through permitted development rights, then I don't think anybody checks it, particularly. But Scott, you can comment on that.
No, when a MCS 020 application is submitted, I'm trying to define what this question is pointing towards. Is it whose responsibility in the planning department is to check these applications? Is that what this question's referring to?
Or who checks the MCS 020?
Who checks it? Well, yeah, at the moment it's down for the contractor or the installer to submit that assessment, or to undertake it, and then it's in I would expect that to be double checked just by the planning department, just to make sure that it meets that 37 decibel limit, not just take the word for it. You got to look at the check the assessment and sign it off.
But yeah, to say that it is the installer's job to fill in the MCS 020A form correctly, and if a heat pump is installed, there was no planning application made because it passed the MCS 020A according to their calculations. If at a later date there was a complaint about it, obviously it would be checked, and if it didn't actually meet 37 decibels at the neighbour's window, then remedial work would be required. To say that complaints are very rare, and there should be more evidence coming out about this, but essentially it is very rare for there to be complaints. And as far as we're aware, when a heat pump has met MCS 020A, a complaint has never been upheld. Yeah, Jack, do you want to go say something?
I think what you've implied there is that the responsibility for the calculation actually rests with the homeowner, although they rarely see the calculations. It's the installer who does it and passes it off, but I think it's the homeowner's responsibility. It's part of, they're the ones who've got the permitted development rights, as I understand it.
Okay, I'm going to move on to another one of Greg's questions, which is, if the air source heat pump forms part of a wider planning application, as opposed to a single application just for the heat pump, is MCS 020A acceptable, relevant in such cases? As far as I understand it, if you're making an application, let's say for an extension and solar panels and a heat pump, if it passes permitted development and it passes MCS 020A, then there really is no reason to be kind of asking for further information or asking for further sound assessments. It just happens to be part of the application, but it would have passed anyway. I don't know if Jack or Scott, you want to add to that?
Yeah, I agree. The 020A assessment can be used in quite a lot of different applications. For instances like small blocks of flats, or very built up areas. So you can apply that calculation to a lot of different scenarios. Mainly, it's preventing, ensuring that there's not going to be any noise complaints. So yeah, you can apply that to different applications.
We see this all the time, and this is exactly why we've written the joint IOA-CIH guidance to suggest that planning authorities do rely on MCS 020A where an air source heat pump is caught up as part of a bigger application, because it's ambiguous at the minute as to whether that's okay or not, and local authorities are taking their own views on that. So that's exactly why we've written that in the guidance. So that should be simpler going forwards.
Makes sense. Okay, I'm going to go to the next question. If it is a design aesthetics planning issue, RAPS, Oh, the brick pattern one. But if the gas electricity boxes are allowed, why would an air source heat pump be treated differently? I mean, I think this speaks to the slides that I was showing, that essentially electricity meters, gas meters, like these things are similar visually to air source heat pumps. We have gas meters, a gas meter on the front of my house, lots of gas meters on the front of houses, lots of people putting in bike storage on my street. I did see another question about this, where obviously different areas will have different approaches, but from Nesta's perspective, we do think that they are necessary infrastructure and should be allowed on the front of houses, unless it's a listed building. I don't know if anyone wants to add any more on that.
Yeah, there are situations where heat pumps will need to be installed in conservation areas. I know they are different to to things like electrical boxes, where the rules on those might be different. But when you've got conservation areas that have more strict rules regarding positioning of heat pumps, that might change the aesthetic of a building, for instance. That's why one of Katie's slides shows you can dress up heat pumps in certain ways to make them fit to fit the area that they're installed in. Yeah.
Great. I'm going to move on to Sam asks, are there products available to dampen the sound from a reflective surface? I'll pass that one to Jack, because I know you've been looking into this.
This is an interesting question, and we're hoping to do, as part of our testing, we're going to test some sound absorption both behind an air source heat pump and behind our calibrated simulated source, to see if we can negate the effect of a reflective surface, or what impact it has on the reflective surface behind a heat pump, to see if that would be an option. There's only a small number of decibels that might be available from that sort of treatment, and it's not simple to do. So I'm not sure how popular it would be, but we'll do some prototype measurements anyway. So at the minute, you can't account for it in, well, you could account for it if you're doing modelling to ISO 9613. You could include the absorption coefficients on that part of the wall.
Great. I'm going to move to Lucy's question around how would you approach a planning application for a large residential development where every dwelling has an air source heat pump? What would a worst case scenario MCS assessment would a worst case scenario MCS assessment be acceptable? Jack, I think your thoughts on this cumulative noise point would be useful.
So yes, so this is a common problem, and what we see is different local authorities taking different approaches to this. And we see some local authorities not requiring assessments at all, and some requiring assessments to be S4 and 4.2 at the other end of the scale. So I think from the work we've done on cumulative impact, we've shown that for terraces or semi-detached houses, using MCS is safe to prevent cumulative impact. And what we've got in the guidance with CIH suggesting that MCS is appropriate to use for planning, then using MCS for each of those assessments is a suitable method.
Great. And then Mark's asked a question about night mode. Can you rely on the owner to have it on? Is it automated, or are you relying on diligence of the owner? I think I would say that this is by heat pump model and by the controls that the heat pump has. But as we said, in European countries, it's very common to have different sound levels or sound requirements for night. So a lot of the manufacturers would have thought this through and have controls that can do this. I don't know, Jack, if you want to add anything more.
Often the controls are behind the installer level menus, so the homeowner can't change them themselves. So that's certainly true with my heat pump. You need an installer code to be able to change that. But I don't know how other manufacturers do that. But there's lots of questions that we need, exactly like that we need to answer, and everybody needs to understand if this was going to become an accepted way of doing things, because it's different from what we do at the minute. So it's a good question, yeah.
Great. I'm going to
sorry, Katie, I was just going to say there's also the fact that, you know, a lot of heat pumps, if they, you know, if they're running at night, what impact does night mode have on efficiency as well? If the, you know, if you're on a plan which, you know, you'd be reheating hot water cylinders overnight, what impact does night mode have on the efficiency and reheat times?
I think from the work we've done that it's likely to increase efficiency, actually, because it's going to limit the compressor speed. And the more you limit the compressor speed, you limit the noise, you limit the delta T, the difference between the flow and return temperature. And these things are all associated with more efficiency, greater efficiency. So it'll take longer to charge the hot water cylinder, but it would use less electricity to do it.
A lower temperature as well, I suppose, yeah. Brilliant.
Great. I'm going to go to Sam's question. I might need some help on this, Jack, but Sam's saying the BS8233 offers a limit of 35 and, you know, a nighttime limit of 30 for bedrooms with a dB correction of 10 decibels for closed windows. Is 37 decibels in the MCS 020A 1 meter from the habitable room not too high?
It's a good question. And so the 37 dB in MCS is essentially a free field level. So it doesn't include a reflection from the facade of the house that you're considering. It includes reflection effects around the source, but not out the receiver. So and I presume you mean an open window rather than a closed window. You say that. So if you allow 10 dB for a 10 dB attenuation is a window open a good amount. I mean, that's not cracked open, that's a window significantly open. So that would be 27 dB inside a bedroom. So that's below the 30 that's in BS 8233, if that's the question. So I suppose your question is 27 from an air source heat pump too high if your overall limit is 30? I think this comes back to the fact that there's overall very few complaints, considering the number of installations that are out there. And of course, not all the installations are on the limit of the sound level that's possible, but there are relatively few complaints. So yeah, we need more information about complaints and about what leads to the complaints. We think nighttime conditions are more important than daytime conditions. What we don't yet know about complaints is the extent to which it's the characteristics of the noise. Is it due to tonality or intermittency? So things which aren't actually assessed under the MCS assessment at all. They might be related to the sound power when it's operating, but they might not. So we need to find out more about complaints and the acoustics of complaints to know if it's the right, or if we're assessing them in the right way overall. By the minute we control the sound power of the source in a particular way, is that the best thing to do? And that's a much bigger question, of course. But overall, it seems to be working, I think, is the conclusion. It's probably too prudent in the way the whole calculation is set up. You know, that I've tried to explain is that the sound propagation model in there is conservative in lots of situations.
Great. I'm going to move to Stuart's question about should be talking about air conditioning units, much cheaper and less invasive than air to water, and they cool as well as heat. So yes, air conditioning units are air source heat pumps, and they would be under what we've been talking about here. At the moment, people tend to install one air conditioning unit, maybe to cool a room or something like that. MCS have recently produced a standard for air to air, is what we'd be talking about, these air conditioning units. And there is now a grant available for air conditioning units or that heat and cool. But to get the grant, you have to decarbonize the whole property. You have to get rid of gas, and it needs to be able to heat and cool the whole property. And so we do expect that people, lots of installers will start to move towards doing this, and there'll be more offers available. But at the moment, we're tending to see that people are not decarbonising the whole heating system with air conditioning units at the moment. But I foresee it's true, and it's right to make that point that in all likelihood in the future there'll be more consumer offerings for air-to-air for these air conditioning units, and then again you need to think about with planning, how can we make sure that people can do that with minimal friction and paperwork. Anyone else want to chime in on air-to-air?
Yeah, well, as you touched upon, Katie, MCS have recently published updates to the heat pump product standard, the design standard, and the pre-sale information and performance calculation. So they are, these updates are an important milestone towards, bringing air-to-air heat pumps into the scheme and into the industry. So there are more steps for it to be, before it's fully implemented into MCS. But we're working on getting this in the scheme, and we'll be providing updates to the industry as this progresses.
Great, thanks. And to say, Tim asked the question, why is noise a consideration for air source heat pumps but not air conditioning units? It should be. The same rules apply for air conditioning units. So sometimes you'll see online that air conditioning providers will say that will imply that you don't need to meet planning, but that's not true. So to say that all of this does apply to them. I'll take one more question, I think, and then we'll have to wrap up, I'm afraid. So Paul says we have architects who reject doing the MCS assessment completely and argue that they don't know which air source heat pump will go in and don't have an air source heat pump engineer yet until the house is semi-built. What would your advice be under these circumstances? You do need to know what the unit's going to be. So I think that's just say you can't do this assessment until you know what the unit you're using is and what sound level that unit makes, and obviously where you're putting it. Does anyone else have anything else to add on this one?
Yeah, you can't. You definitely need to select the model first, because you need to know the specifications of it. You need to know the sound power levels that that heat pump's going to be emitting. So it's definitely a requirement to have that before the assessment. Yeah,
I would say the other thing you can do is essentially carry out the MCS calculation and work out what the sound power limit is for an air source heat pump at that location. And the problems with doing that is it partly depends on the size of the unit, about when you're going to attribute any barrier attenuation. It depends on the size of the unit and its separation from standoff distances and clearances and things. But if there's no barriers involved, you can essentially do the calculation and specify the sound power limit for a heat pump that would go in that place. But that's obviously not a compliance calculation. That just becomes a performance specification for an air source heat pump at that location.
Brilliant. I think we're at time. So thank you very much for joining us. And we'll send round the link so you can apply for the CPD certificate. And to say that the deadline, we said before, but it will take a while for the certificate to be issued. Brilliant. Thank you so much. And thank you, Scott, and thank you, Jack.
Thank you very much.